Now, welcome back again. Another problem and solution to problem set 2.3, solution to 2.33, engineering mechanics by Professor Timoshenko. Now, the statement is like this. A weight Q, if you look at here, this is a weight Q, P is also a weight, another weight P. A weight Q is suspended from a small ring. This is actually a thread cord A, C, B, and from here a weight P is hanging. And this weight Q, there is a ring like this, and weight Q is suspended from it, right? The moment you let it go, the ring will slide down and will come to the point C, and at the point C it will remain like that, means it will at an equilibrium. The system will act at an equilibrium. Supported by two cords AC and BC. AC is a cord, BC is a cord. As in figure L, the cord AC is fastened at A, AC is fastened at A, while the cord BC passes over a pulley here, passes over a frictionless pulley at B, and carries the weight P as shown. If P is equal to Q, the value of load P and value of load Q are equal, and given alpha is equal to 50 degree, find the value of angle beta. So what is given, I have written here, P is equal to Q, alpha is equal to 50 degree, beta is to be found out. Since AC and BC are cords, the axial forces are tension forces and will be acting away from the point C. Now look, let in the cord AC, the axial force tension force is S1. And in the cord BC, it is equal to S2. Now, for the point C, it is acting, S1 is acting to this side, from the point C, S2 is acting to this side. It is the same cord, so this will be also your S2. And this is your weight, the load P. So P is equal to S2. So P is equal to your S2. Now, why this S2 and S1 are acting away from the point C? Very simple logic. Suppose you are standing here, and here is your friend, and there is a cord that you are holding, and it is tied around your friend. You cannot push he is your friend, and this person is you. You cannot push your friend to this side with the cord, but you can definitely pull him to this side, right? So this is away from this point, right? That is the simple logic. So for the point C, S2 is acting away from it, and for the load P, S2 is acting away from it, because it can withstand the load. This tension S2 cannot push it, right? So that is what I have said. So let it be S1 in the cord CA acting away from the point C, and S2 in CB acting away from the point C. And P is hanging from the free hand. The load P is hanging from the free hand. Therefore, S2 is equal to P. So your S2 is equal to P. And again, since P is equal to Q, it is given. Therefore, Q is also equal to, numerically equal to your S2, right? So, now the forces are concurrent. At the point C, there are three forces, one to this side S2, one to this side S1, and one to this side Q. This angle is alpha given as 50 degree. This beta is to be found out. So, this is the point of concurrence, and these three forces, S1, S2, and Q, they are lying on the same plane and passing through the point C. They are concurrent. So we can apply Lami's theorem. So I have written the figure diagram again for you. At the point C, S2 is to this side, S1 is to this side, the tension force. This is given as 50 degree. This beta is to be found out. This is your load Q. So at point C, if you apply Lami's theorem, since the system is in equilibrium does not mean at rest. Means sigma F is equal to 0. So Q over sine of this angle, sine alpha plus beta, is equal to S1 over this sine of this angle, that is sine 180 minus beta, is equal to S2 over sine of this angle, that is sine 180 minus alpha. I'll put the value of alpha in the long run, not here. So if you consider these two equalities, that is Q over sine alpha plus beta is equal to S2 over sine 180 minus alpha, and this same thing as this, S2 over sine 180 minus alpha, and since S2 is equal to Q, because S2 was equal to P and P was again equal to Q, so I can substitute Q for S2. So Q cancels now. Now if you cross multiply, your sine alpha plus beta becomes sine 180 minus alpha. If you take inverse sine functions, therefore alpha plus beta is equal to 180 minus alpha. I take this alpha to the right hand side, your beta becomes 180 minus alpha minus 2 alpha. Now I put the value of alpha, which is given as 50 degrees. So 50 into 200, 180 minus 100, that is beta is equal to 80 degree. That's all.